Can you guys do question one, please? Guys, can you do question one, please? You have a good weekend, guys. No? Not good. Oh yeah, let's do question one, guys. Not many people are coming to the transport. I don't know how are you. Yeah, we'll do sheet 6 next week. We'll do it next week. You haven't got check?
Thank you.
You got set?
Yeah. I don't think you got 5.
5?
5, 6.
Just do question one, please. Guys, how are you guys? How was the exam last Friday? We had a weekend, right? On Friday. Was it good? You guys okay? Alright guys, so this is, can you listen if you haven't done question 1 guys? So you're asked to show that this is equal to this. So you can start from the left hand side or the right hand side. Alright, you can start from the left and show that it's equal to the right, or start from the right and show that it's equal to the left. Now I would prefer starting from the left hand side guys. Yeah? So I want to start from the left hand side and show that is equal to the right hand side. Okay? You see why I'm doing that in a minute. You see why I'm doing this. The reason I'm doing that is because oh, did I make a mistake? Oh shit. Sorry guys. Shit, I wrote the question. You should have told me, guys. The question was like this, right? Yeah. All right. Okay. The question was this. There's a new. This should be mu, guys. And this should be x bar here. All right. Yeah. You see what I've done, guys. I have subtracted x bar and added x bar, so I haven't changed anything. The reason I'm doing this is because if you look at the right hand side, both terms, this term and this term, have x bar in it. All right. So that's exactly why I have introduced x bar here. You got a sheet. You have okay. Right. That's you see, that's the reason I have introduced this and this is because on the right hand side you have two terms. Both terms have x bar in it. Right. Now let me put brackets around this. Brackets around the first two terms and the brackets around the last two terms. Then expand the terms. If you expand the terms, you get 3. This is the first term. The second term is this. The third term is this. Yeah. So you get 3 terms, guys. Yeah. Remember, when you do a plus b squared, you get a squared plus b squared plus 2ab. So these 3 terms, right? Then take the sum inside. You get You get the first sum, the second sum is this one. The third sum is this is the third sum. Yeah? You see, I've taken the summation inside the square brackets. You get 3 sums, right? Next thing to do, guys, is now what would this be equal to, guys? Tell me. What is this equal to?
N times x bar minus mu squared.
Yeah, exactly. Because why? Because the reason is that because you are summing a constant from I equal to 1 to n. So you should sum a constant from I equal to 1 to n is simply n times the constant. So it's n times x bar minus mu squared. Now, over here, guys, this guy and this guy are both constants. The 2 is a constant, x bar minus mu is a constant. So you can pull them outside, and inside the sum you have xi minus x bar. You alright? Are you guys with me so far? Yeah. Alright, the next step. Now, what I'm going to do here, guys, is I'm going to take the summation inside the open brackets. So what you will get is the following. You will get the sum of xi minus the sum of x bar, I from 1 to n. Yes? All right. So we are not far off. We are almost there, guys. So bear with me, just for a sec, guys. We are almost close. Now, the sum of xi can be written as n times the sample mean. Yeah. Yeah. Now, the sum of x bar, I from 1 to n, for the same reason as you said, is equal to also n times x bar. Yeah, because x bar is a constant with respect to I. So if you sum it from I equal to 1 to n, you get n times x bar. But sum of xi is also n times x bar. So this guy here is equal to 0. So we have proved that the left hand side is equal to the right hand side. Okay? Is that clear to all of you guys?
Yes.
You okay? You Question 2, we did in class last week. We did this question last week in class. You don't remember? You should look back in the scan notes, you will see that. Yeah. Alright. Guys, this is clear to all of you, by the way. Yeah? Now, question 2, we did in lectures. We did question 2 in the lecture last week. Yeah, this question 2. Question 3 is too hard unless you want to try to become the next what do you say? I don't know, I forgot the name, guys. Anyway, question 3 is hard, too hard. Don't try. Okay, guys. Okay, can you now do question 4, please? Can you now do question 4, guys? You're right. Oh yeah. Sorry, I forgot. Oh yeah. Sorry, guys. Sorry. Yeah, thank you for reminding. I completely forgot. Is it coming there now? It's coming, right? Is it not coming on the? Is it coming on the screen now? Yeah, it's coming. Sorry, thank you for reminding. I completely forgot. Your assistant. You're having a good time. Can you ask the questions more now? Oh, you got good. How was the test last week? Was it good? So you have it when we took so far from each other. Yeah, but you don't need to worry about it. Then after that you All right, guys. Let's see how we can do question 4. All right. Shh. Can you guys listen? If you haven't done question 4, then you listen to me, please. You're told that the sample size is 20. Yeah, you're told that your sigma squared is equal to 1.4, and you're also, so the question is to find the question is to find 2 points A and B, so the probability that S squared is between A and B is equal to 95%, right? Now to do this question, you need to use equation 72 in the lecture notes, right? Now what's the definition of S squared, guys? Sample variance is equal to? Right, this is the definition of sample variance. Remember, this is how we define the sample variance. Yeah? Yes? Yeah? Okay, good, guys. All right, now I'm going to multiply I'm going to multiply this, and this with respect to n minus 1, or by n minus 1, so you get this. Yeah? So I have multiplied this, and this by n minus 1. And you see in a minute why I'm doing this, guys. Then the next step, I'm going to divide all 3 terms . I divided each of these 3 terms by sigma squared. The reason I have done that is because there's something special about these guys. What can you say about these guys? Yeah, exactly. It has a chi-square distribution with n minus 1 degree of freedom. Exactly. So this, if you look at equation 72, if you look at equation 72 of the lecture notes, you will see this has a chi-square distribution with n minus 1 degree of freedom. Yeah. Typically, guys, if you plot a chi-square density function, if you plot the density, the PDF of a chi-square distribution, it looks like this. This is the typical shape of the PDF of a chi-square distribution. Now, what we are looking for, listen, guys, please. What we are looking for are 2 points, this point and this point. So the probability that it lies between them is equal to 95%. All right. So let me use my right. We want 2 points, this point and this point. So the area between them, this area here, is equal to 95% of the total area. So if this area is 95%, guys, this area and this area together should have 5%, right? Now, it's difficult to say, like you could have 1% here, 4% here, or you could have 4% here or 1% here. or you could have 2% here and 3% here. But to be fair, guys, let me take this to be 2.5%, and let me take this to be 2.5%. So the total area under the curve is 100%, right? Now, if this is 2.5%, guys, if this is 2.5%, then this point must be the percentile of the chi-squared with 0.025, and this point must be the percentile corresponding to the probability 0.975. Okay, because 97.5% is this area and 2.5% is this area. Yeah. Okay, so what we are saying is that this guy here must be equal to this, yeah, and this one here must be equal to this, right? So we have two equations. The first equation is that it's equal to, yeah, and the second equation okay, yeah. So you see how I got this, guys? Yeah. Yes. Now from these two equations, we can solve for A. The question is to find the value of A and the value of B. We know what n is. N is equal to 20. Sigma square is 1.4. You can read this from the tables. In the exam, you will get tables for reading these two numbers. So you know everything except A and B. So you can use these equations to solve for A and B. Yeah. So that's it, guys. Right? I'll leave the rest for you to do. Is that clear, guys? Well, your answer. Yeah. And you do now question 5, please. Question 5 also, you need to use equation 72 to do question 5 too. The one I used for the yeah. You have the notes. Well, I'll show you this note. all signed the attendance sheet, guys. Yes. Anybody who hasn't? You sign?
Yeah.
Yes. Alright guys, this is question 5. Now question 5 says your n is what? What is the value for n in question 5? 16. And what is s? 2 point? And what is sigma? 4.5. Okay? Now equation 72 by equation 72 this must be equal to what? Now can you tell me what this is equal to, guys? 1 divided by 4.5 squared. Now what is this guy equal to? N minus 1 times s squared, which is 2.2 squared. Alright guys? Yeah, and n is, we know what n is, okay, n is 16. So 16 16 minus 1 times this. So this is equal to 15 times 2.2 squared divided by 4.5 squared. Yeah? Are you guys with me? And this must have a chi-square distribution with 15 degrees of freedom. Now, let me ask you now a question. How do we check? Remember, what you have here is a single number. How do you check that a single number follows a certain distribution? Any ideas, guys? Now, if I give you a number, say any number in the world, and ask you to say, ask you that if it follows a certain distribution, how would you check that? Now, what I have plotted here is the PDF of a chi-squared 15 distribution. Now, if this number, whatever this number is, if it actually follows this distribution, right, you would expect it to fall. You would expect this number to fall in the center of the distribution. You should know what I'm saying. If a number follows a certain distribution, it must fall in the bulk or the center of the distribution. Yeah. So when I say center, I mean take off the extreme part. This is very extreme. This part is extreme left. This is extreme right. So let's say, suppose this is 5%. Suppose this is 5%. Sorry, 2.5%. I mean 2.5%. Suppose this is 2.5%. Right. So the remaining area between this point and between this point here, this is 95%. So 95% is can be considered the bulk of the distribution. In other words, the center of the distribution, right? So if this number here, right, if it falls somewhere here in the center, if it falls between this point and this point, then you can say that the null hypothesis is accepted. You know what I'm saying? Does it make sense? If it falls in the center of the distribution, meaning that it falls between these 2 points, then the null hypothesis is accepted. If it falls over here or over here, I mean this is extreme left and this is extreme right, then it's unlikely that the null hypothesis is accepted. So you wouldn't expect a number that follows a certain distribution to fall in the extreme corners of that distribution. This is the extreme left corner. This is the extreme right corner, right? If the number follows that distribution, you wouldn't expect it to fall over here or over here, right? So the answer to the question is the following. The answer is that we accept the null hypothesis that sigma is equal to 4.5 if the number, this is the number, yeah, falls between this point and this point. This point here is the percentile of chi-squared 15 with 0.975 area above it, and this point here is percentile of chi-squared 15 with 0.025 above it. So that's the answer, guys. I hope it makes sense, guys, because the argument is that that if something follows a certain distribution, you would expect it to fall in the central part of the distribution, not in the corners of the distribution. So that's the argument. Yeah. Are you guys okay or not? Yeah. All right, sir. All right, can you do question 6, please, now? Yeah, that's because of the definition of sanctuary. We don't know, like, remember, S squared is 1 to 1 over n minus 1 and the sum of xi squared 5 to 1. So this here, see, this here is n minus 1 multiplied by x squared. That's what I have done. 6 multiplied by x squared. Yeah. Can you guys do question 6, please? You guys all right?
They should say 2.5%, okay?
Yeah, hi. Yeah, yes. Yeah, I know. What we have done here is to compute this, which according to equation 72 must have a chi-square distribution. So it's 15 degrees of freedom. Yeah. If you look at the left equation 72. You don't have a shape. According to this equation, this number here must have a chi-square distribution. 15 degrees of freedom. Now, if that is so, then you will expect this is the typical shape of a chi-square linear 15 degree of freedom. So you would, if this actually follows this PDF, you would expect it to fall in the central part. The central part is that means if you point to cut off the bottom 2.5% and the top 2.5%, cut them off, then you would expect this value to lie between the 2 points that are marked in red. You can see the 2 points that are marked in red. You will expect this point to lie between those 2 points. So if it does lie between those 2 points, you accept the hypothesis. You accept the hypothesis. If it doesn't lie between these points, then you reject the But you have to, if you change the volume of sigma, then you need to recompute this. You need to recompute this. And then check whether it belongs to the central part of the video or not. Yeah. Are you? What about you guys? Did you guys follow what I said? You guys do question 6, please, now. guys, can you listen to me, please? Now, you have a variable x. I'm using different a and b instead of new 1 and new 2, okay, just for convenience, right? So suppose x follows an f variable with parameters a and b. Now this implies, according to the lecture notes, I'm trying to find the lecture notes, equation 82, I think.
Yeah.
Is that 82? Yeah. Yeah. If you look at equation 82, guys, by equation 82, you can write x as the ratio of these two chi-squared variables, right? Now, if you do 1 over x of this, you get 1 over this, which is chi-squared b divided by b, a divided by a, right? Now, this must imply by, once again, equation 82, that this, what you have here, must be an f variable, but with this time parameters switched around, that is with b and a. You guys follow? Yeah. So that's the proof for question 6. Now the second part, I'm run out of time for question part 2. Can you try for homework, right? Do part 2, that is, you need to, the second part of question 6, guys. Can you try by yourself, guys?
Sorry, we want the alpha 1 minus alpha.
That's the percentile. It's the percentile of the distribution. It's percentile. So basically, you need to show that f you need to show this. It's a percentile, meaning that, for example, if this is the PDF of FAB with what, right? Then if this is the PDF of FAB, then the point over here that has an area above it equal to, if this area is equal to 1 minus alpha, if this area is 1 minus alpha, then this point is equal to FAB comma 1 minus alpha. Yeah, that's how you define it. So if this area is 1 minus alpha, then this point is defined as this. Yeah. Okay. Just try to prove it by yourself, guys. If you have problems, always see me. Right? See me whenever you like. Oh, yeah. Alright, guys. I'll see you guys tomorrow. Any questions, send me an email or see me in person.
Yeah.
Yeah, I can give you this one. All your friends have copies? Oh, yeah. If they don't have a copy, I can receive it. I can give them copies. I've got plenty of them in my office. I've got plenty of hard copies. Do you have this one? Alright, see you. See you guys. Bye.
我就选择先去。
等一下，我要写。